All right. Well, thank you guys for staying around and listening to what we have to say. We've got some exciting things going on. I thought I'd give a real quick brief about our company just so you'll know who we are. We're very vertically integrated, which I think is a key strategy to what we're trying to do. PRUF Energy Solutions is the parent company, but we do have 5 divisions. We have our own R&D division. We do our own manufacturing as well here in the U.S., which gives us a lot of ability to do quick prototyping, also to do extensive quality control, being able to do our own manufacturing, and then being able to be nimble and get the latest technology to the market. We also have LED lighting. We do design and develop and manufacture our own LED lighting fixtures. We also have energy controls, a proprietary system, and that's what I'm going to spend my time talking about mostly today. Energy controls, and then we also have a division that provides the energy management suite. The actual services are where we go in and help with energy optimization utilizing the control system. Next slide. This is the LED technology division. Just shows you some of the things that we can do there. Next slide. Energy controls, which is actually the hardware and the software. We've developed both the hardware, the components, and the back-end software for handling all the data, and front-end software for customer interface. Manufacturing, as I spoke of, we actually have our own manufacturing facility in Waco, Texas, based there. We have our own surface-mounted technology. We actually populate our own boards, circuit boards for the LED lighting, and also the circuit boards for the controls themselves. And then the energy management suite, key here in that we do actionable data analysis, prognostic systems monitoring, energy optimization, and facility occupant enhancements as well. So quickly get through that. I want to talk about what we actually do. On the R&D, yes, we do our own performance testing. We make sure we meet all certifications. This is where we do all of our patent technology for the patents that we have filed. And then obviously we have industry expertise as well. This is what I'd like for you guys to really pay attention to. This is where we feel like we are very different in how we have approached utilizing and making the most out of energy efficiency within a smart building. And I'll talk about quickly the components of this. Maybe hard for you guys to see. The biggest difference in ours, LED lighting does allow for a lot of programming of the lighting itself. Our system, though, not only interacts with the LED lighting, it also interacts with the plug load. Most systems that are out there today, and the way that they interact with the individual is through motion sensors. We actually utilize an active RFID tag. We call it a proximity tag, whether that's a badge or a key fob or any other component that can actually house our circuit board. It allows us to be able to have the individual's tag and ID number interacting with the lighting and the plug load, which it gives us a lot of different capabilities. Once the LED lighting has been put into a facility, whether that's in a facility here in the States or out in the field, you end up with a digital grid. And with that digital grid, we're able to do a lot of things in regards to collecting very granular data at the fixture level, but also being able to send commands to each fixture and to each plug load as well. So if you'll notice down at the bottom left, there's the individual with the proximity tag. That signal is going to both the plug load and it's also going to the LED fixture itself. That information is then being collected by a receiver and it's sent back to a database, and all this is done over a very secure connection. That data is then analyzed, which allows us to do a lot of things. We analyze that data. We then calculate where we can see the most in energy savings. We optimize that over a period of time based on human behavior, not based on scheduling, but actually human behavior. And then we're able to do that to allow us to do not only global commands at a facility level or facilities level, but all the way down to an individual fixture or something plugged into an individual plug. All of that information we collect, and as you can imagine, we're collecting millions of data points because we're getting something from every fixture, from every plug, not only in regards to energy usage, but also we're monitoring activity and behavior of individuals and pieces of equipment. So this allows us to literally watch behavior over a period of time and then be able to go back and optimize a facility based on that data information we've collected. Very, very informative. We are collecting amazing information in regards to just how things are being used, temperature in certain rooms, because each fixture has its own temperature probe. We're able to interact with any particular sensor, but what begins to get very interesting is the behavior of individuals and being able to have hierarchies. So I give you an example to where maybe even in the field, you could have certain individuals who come in, the light levels go to a certain level for them, and then you have another person who comes in and maybe that light level is either going higher or lower, or it's changing. This is all done automatically. There's nothing that the individual's having to do. So all of that data is collected, monitored. It allows us to also go back and affect demand response. You guys may not know, but the typical facility utilizes, in regards, about 50% of that energy pie is utilized by HVAC, heating and air conditioning. The other 50%, or 40 to 45% of that, is light fixtures and plug load. The difficulty in past has been being able to control those at a cost-effective way, because obviously you've moved from a few huge pieces of equipment with HVAC to literally hundreds or thousands of fixtures and plug loads. Very difficult in the past to be able to control. We've come up with a wireless technology that allows us to do that and to collect that data at a very granular level. Allows us to be able to watch, control, monitor, and optimize energy at a facility level, a floor level, a division level, a room level. It gets very, very good. Next slide, please. This will give you another little example. If you'll notice that the lady sitting here, basically what we've done is we're building individual clouds. And that cloud is reacting to that individual's fob or badge or proximity tag. And based on where that individual moves within the facility, the lighting and the plug loads are reacting to that individual. So to give you some examples, you may have common areas where you've got hallways or areas where everybody is throughout the day. You have those lighting and plug loads reacting to what's going on within those areas. But then as people move to their individual offices, their individual divisions, you're able to then have lighting and plug loads react to those individuals as well. Really, really hard to see, but I wanted to give you an example. This is just an individual office. There's two fixtures. This is just a small sampling. There are two actual light fixtures, and then there is a power strip. And if you can see, you'll notice that the blue line is the power strip. So if the individual has left, and everything that's non-critical that's been plugged into that power strip is now turning off. And this, again, is based on distance away from the office or away from the area, not motion. So by the time that individual walks back into the room, that power strip and all the things that were plugged into it automatically are back on. So by the time the individual sits back down at their desk, everything is back the way it was before they left. And so you'll notice that the blue actually pops up there to the top, and that is the activity you can see that the individual, while they were in the office. You'll notice again the blue drops, the person left. The blue goes back up, they were in their office, the blue drops, the person left. To give you an example. The red and the yellow, which again are probably hard to see, are the fixtures. And why I point those out as being different, they actually go to on when the person's coming close to the room. This particular individual wanted their lighting at 60% of capacity. I wanted it at 60%. And so what's happening is we're dimming the lighting over a 15-minute period of time, so the eyes are adjusting. This has gotten down to 60%, and that's why you see the graph gradually dropping down, because it's going to 15-minute intervals. What's unique about this is now you've got an individual, and we've gone and done this in situations where, let's just say we take a floor or a division, there's 40 people. As we are commissioning these systems, we're able to go to each individual and say, what do you want your light level to be at? And we're finding that it's anywhere between 40 and 60% off of LED. So what's significant about this is that once you go from traditional lighting to LED, you're gaining about 45% reduction. We're finding that individuals actually want the lighting to be at another 40 to 60% below that. So we now have moved a traditional light fixture that is running at 100% all throughout the day, unless they have motion sensors, to actually dropping 75% from traditional lighting. And when you look at doing that for every fixture, it begins to be significant savings in energy. So as you see here, it says 47% above and beyond the 45 to 50% we've reduced when we just went to LED lighting. Next slide, please. Thank you. This here shows you just on the power strips. The blue bars are showing without controls. The red is when we use the smart power strip to be able to plug in things. And so you can see the significant energy reduction that we saw every day just by having the smart power strip. Next slide, please. This here is showing for you, the blue is without an occupancy sensor. If you're asking or wondering, are we any better from a standpoint of cutting off the lighting than an occupancy sensor? The difference between the red bar and the green bar during the weekday is what we are gaining above and beyond occupancy sensors. And this is just turning off and on. This has nothing to do with the dimming capabilities while the individual is in the office. Next slide, please. So let me touch on something that this is great. You guys have figured out maybe an effective way to reduce energy even more. What's very unique about this, and what begins to get exciting about this, is what we call real-time location services. This is an ability now to move into where we've put a digital grid in with lighting, smart lighting, and we've been able to also do this with the plug load. So we're not only affecting the energy reduction on almost half of the energy usage pie, we are now being able to, because we have a monitor in every fixture and every plug load, we're being able to monitor down to about 6 feet at this point, if not 4 feet, of where an individual is and who that individual is. Now you begin to think about Big Brother and all of that. There are ways to keep to where that information about that individual is not going back to any database, but it is capable to be able to do that as well. So you begin to get into all kinds of security possibilities with this. You begin to be able to watch patterns in regards to patterns of traffic. And I'll give you an example. We have done a project with the AUSA headquarters, and we've put in lighting there for them, the LED. The next step is to put in the controls, and they're going to begin to watch the behavior of their employees and see how that works. And one of the discussions we're having in regards to a new project they're doing, they want to be able to watch the user who comes into the facility and how they may move from one exhibit or one area to the next, and know traffic patterns from gathering this data. So we've been able to take the energy reduction, lighting and plug load control technology that's proprietary to us, but that idea, and the real-time location services, and we've overlapped those two industries. And we've now made real-time location services very cost-effective because we're going to have an ROI in regards to the energy reductions that we are bringing to the table. So we have been in discussions with, and we are in the healthcare industry, we're in the government industry, military, we're also in the education industry in regards to schools, and in the commercial real estate applications as well. That's it. Moving very quickly, but that's an overview. Any questions at all?
Okay, sir. Thank
All right,
you so
great.
much.
Thank you.
Right.